So Algebra 2 5.1 should be the easiest section you've had in quite some time. This is all old stuff, it's all Algebra 1 stuff, and it's like pretty common Algebra 1 stuff. Chapter 5 overall will have a mix of some old and some new. Well, today we're going to review a little vocabulary and then step into some, it's going to be the easiest homework set you've had in quite some time. So first word of the day you need to be reminded of is what a polynomial is. Through the course of the chapter I'll use the word polynomial about 1,000 times. So a polynomial is just a sum, meaning we can add, or the difference, meaning we can subtract, of monomials. And that isn't maybe that helpful, the definition, unless I tell you what a monomial is, so we'll get to that in a minute. So again, a polynomial is if we're adding or subtracting a thing called monomials. Monomials can also be called terms. Those are synonym words. What a monomial or a term has is a real number, which is often called the coefficient, or it can have a variable, or it can have a product, meaning multiply those together, like 7 is a real number, so that's a monomial. X is a variable, so that's a monomial. Or 7x is multiplying real numbers and variables. It's the product part of this. That's also a monomial. So monomials are called terms. Binomial is going to be a polynomial specifically that has two terms, and that shouldn't be too shocking. The prefix bi always means two, like bicycle has 2 wheels, or a million other words that start with bi is a 2-word. Trinomial is going to be a polynomial that has 3 terms. Like a binomial might have been x plus 2. A trinomial might be like x squared plus 2x plus 3. And binomials have 2 terms, trinomials have 3 terms. That shouldn't shock you because tri is a prefix that always means 3, like triangle or a million other words that start with tri. But all of these would be examples of polynomials. So back here I said 7, I said x, I said 7x. Okay, each one of these is a monomial. This with 2 terms is a binomial. This with 3 terms is a trinomial. But all of these things, check, 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 they all fit into the category of polynomials. They can be adding or, change this one, subtracting. If we're adding or subtracting those pieces, we have polynomials. The first, I think this isn't new, but the first thing you might need reminded of a little more is the degree of a term. Every term has a degree. How you spot the degree of the term is you look at all the variables in that term, look at all the exponents on all the variables on those terms, and we do the sum of those. So like this individual term right here would have a degree of 2, because the only exponent we have is a 2. The degree of this term would be a 1, because the only exponent I see is an invisible 1. It's there, it's invisible, but the degree of this would be 1, because the exponent on that variable is 1. The degree of this would be 0. There aren't even any variables. So there can't be any variable exponents. If there aren't any variables, there would be 0 degree for a number like that. Another word back from the past, the degree of a whole polynomial would be picking the highest degree of any one of the terms. So this term had a degree of 2, this term had a degree of 1, this term had a degree of 0. So the degree of that whole polynomial would be the 2 that was the biggest number that I said a minute ago when I did that. And the last word of the day before we start doing stuff is descending order. Most polynomials in our book and in your answers are going to be written in descending order, which means you pick a variable, usually x, and then you're going to sort them from the highest variable power to the lowest variable power. Like here, I just did that naturally. I did the x squared, which was the biggest power of x, then an x, and then something that had no variables at all. I usually save till the end. But that's our words of the day. Polynomial, add or subtract monomials. Monomials can be real numbers or variables or multiplying those guys. Binomial is a kind of polynomial that has 2 terms. Trinomial is a kind of polynomial that has 3 terms. Every monomial, every term has a degree. To find the degree, we look at the variables, we add up all the powers we can find. Then the degree of an entire polynomial is just us picking the highest one. So let's stroll over here to the right for Hallmark type problem 1. If you want to take a peek with me at the page where you're going to be going, we could look at 211. 211, the first thing they do is give you a polynomial, and they'll ask you to decide what's the degree of each term, as well as what's the degree of the polynomial. Well, I'm going to go you one better than that. I'm going to make a little bit bigger list than what they have you doing. If I give you this polynomial, and I ask you first how many terms are there, we'll just count 1, 2, 3, 4, there are 5 terms. If I asked you to list the terms, this is a list of the terms, 5x squared is first. I'm not going to write the plus sign. Okay, the next term I encounter is positive 4, xy squared z cubed. The next term, I am including the minus sign. Okay, the minus is attached to the 4, so the next term has negative 4, xy. The next term is positive 3z, I'm not going to write the positive. Then the last term is negative 7, I am writing the negative on the 7, that's my 5 terms. If I ask you for the coefficients, we just have to look at the real numbers, the numbers in front. Okay, so this has a coefficient of 5, this term has a coefficient of 4, this term has a coefficient of negative 4, the negative terms have negative coefficients. This has a coefficient of 3, this has a coefficient of negative 7, that's the numbers, the coefficients. For the degrees, we're back to the definition from a minute ago. The degrees, we have to scan for variables, find their exponents, add them all up. That's going to give us the degree of every term. So the degree of this term is 2. The only power I see is the 2. The degree of this term is 6. Because there's a 3, a 2, and an invisible 1, that if we add up all those variable powers, it'd be 6. The degree of this term is 1 plus 1 from invisible 1s to make 2. The degree of this is just a 1 from the invisible 1s. And the degree of this is 0. There are 0 variables in play there. And then the degree of the polynomial, remember from a minute ago, it's the highest degree of any term that we found. Well, we just listed 2, 6, 2, 1, and 0. The highest one we listed in our list was 6. That's the degree of the polynomial. So homework, when we get there in a minute, the first 6 to 11, we're not going to have to list the terms. And you're not going to have to list the coefficients. I think when we take a quiz, I ask you to do that though. But the homework is going to ask you make a list of the degrees of the individual terms and then the degree of the polynomial. Second homework group is going to ask you to add polynomials. This would be an example of adding polynomials. If you're peeking at 211, looking at 7 to 12, those are examples of adding polynomials. Adding polynomials has an old name to this. If I were here, I'd ask you, and then we could stare at each other for 5 minutes sometimes, as we're prone to do this year with each other when I ask a question. But if we're going to add polynomials, all that amounts to is for us to combine like terms. If we can combine like terms, we can add polynomials. That's all we're going to have to do on this next proof. Anytime there's parentheses with nothing in front of them, that's worthless. Anytime there's parentheses with a plus in front of them, that's worthless. We just have to combine like terms. So if we look at the x squareds, don't change the x squareds. When you add like terms, you don't change the variables, you just add the coefficients. So positive 4 with negative 7, the negative there wins by 3 when we offset those. In X world, there's a positive 3 and there's a positive 5 that can collaborate to make positive 8. And then in the number world, there's a positive 3 that's going to get offset by the negative 9 to be negative, winning by 6. We're thinking here back to the add rules. When the signs are the same, we add the numbers, keep that sign. But if the signs are different, go with the bigger one and then subtract to get a result. So we should be good there for a while. Then the last little bit of homework has to do with subtracting polynomials. To subtract polynomials, what we're going to look to do here is distribute the negative sign through the second set of parentheses, which is going to mean to change a lot of signs in the second set of parentheses. So this would be negative 7x squared, a plus 8x, and a minus 3. Subtracting, we're just going to need to change the signs on the back half. The first half is just going to sit there exactly as it is unchanged. So that's plan A. Plan B is to combine like terms. So the first one stayed the same. The second one we did all those sign switches. Now we look to combine. In x squared's worlds, we have a positive 5 versus a negative 7. So negative wins by 2. In x's world, we've got positive 4, positive 8, so put them together for positive 12. And then in the negative, or in the number world, positive 3 versus negative 3 is just complete annihilation. Nothing would be left there. We don't even have to write a number. If you insisted on writing a plus 0, I could live with that, but it's really not a thing you need to do. If we peek at the homework again, 211, 13, and 14, all they want you to do is this like little half of a problem here. They give you something with a negative to distribute. Just switch all the signs. That's all you have to do on 13, 14. 15 to 18, there's another part of the problem to copy. Switch those signs on the back half, and then they want you to combine the like terms. And the homework goes, I believe, to 18. Check. Yeah, 211, 1 to 18. So I can't imagine this took very long. That was probably about a 10-minute video-ish. So I would look now to take your next 30 minutes and just try to get this 211 done. And then I'll see you tomorrow for some 5.2, which will also be an old familiar friend. So that's it.